This is example 6 in section 4.9. In this question, for this relation implicit, we want to find the second derivative of y with respect to x. So we're first going to find the derivative, and then we'll find the derivative again. So the derivative of the first term would be 6x squared times dx dx, but we know that cancels. We have a 6y dy dx, because we're differentiating the variable y with respect to x, equals 0. So we only have one dy dx, so I can isolate that. And then I can divide by 6y to get dy dx by itself. So I end up with x squared over y for my first derivative. Now I'm going to calculate the second derivative by differentiating again. So the second derivative of y with respect to x squared, I'm going to do the quotient rule because I have division. So we're going to take the bottom times the derivative of the top, which is dx dx, minus the top times the derivative of y, which would be 1 dy dx, all over the bottom squared. So we'll tie this up a little bit. We have 2xy over y squared, and we have x squared over y squared dy dx. Now, we're trying to find the second derivative, which we know we have it isolated, but we have a whole bunch of terms here. Now, dy dx we've already found. Dy dx from here was x squared over y. So I can substitute that in. And that's the trick here. So we have an x squared over y squared, and I'm going to sub in an x squared over y for this dy dx. And then I'm just going to do some algebra and multiply it out. So I have 2xy over y squared minus an x to the 4 over y cubed. I can see that one of my y's cancels, so I have a 2x over y minus x to the 4 over y cubed. Make sure you keep saying it equals the second derivative. Mathematically, it has to equal something. And then I see that I can get a common denominator here, so I'm going to multiply this by y squared and do it to the top. So I have a 2x y squared minus x to the 4 all over y cubed. And that's the second derivative of y with respect to x squared.